Routine Neptune observation, September 2024. Webb's infrared sensors suddenly spike. Massive thermal bloom. Energy signatures off the charts. Within hours, astronomers realize what they're seeing. Something enormous just slammed into Neptune at 50 kilometers per second. What would happen if Webb actually caught a collision like this? Let's find out. Neptune doesn't get much love. It's the 8th planet, lurking in the frozen darkness at the edge of our solar system, so distant that sunlight takes over 4 hours just to reach it. Most of what we know comes from a single spacecraft flyby, Voyager 2, way back in 1989. Since then, Neptune's been mostly forgotten, just a faint blue whisper in our telescopes. But don't let that fool you. This ice giant is ferocious. It has the fastest winds in the entire solar system, screaming at over 2,000 kilometers per hour. Storms bigger than Earth rage across its methane-rich atmosphere, and beneath those swirling clouds lies a world we barely understand, with pressures that would crush steel like paper. Now imagine something massive hits it. Not a gentle tap. A full-speed, catastrophic collision with an object maybe hundreds of kilometers wide. The kind of impact that doesn't just disturb the atmosphere, it rewrites it. And for the first time in human history, the James Webb Space Telescope would be powerful enough to watch it all unfold. Here's the terrifying part. The object wouldn't announce itself. No warning signs, no emergency broadcasts, just a dark mass of ancient ice and rock hurtling through space at unimaginable speed. By the time Webb sensors picked up its heat signature, it would already be seconds from impact. And the size, we're not talking about something the size of a city block. Think bigger. An object 50, maybe 100 kilometers across. The asteroid that ended the dinosaurs was only 10 kilometers wide. This could be 10 times that size, carrying enough kinetic energy to release the force of millions of nuclear bombs in a single, blinding instant. Neptune's gravity would yank it inward, accelerating it even faster. And then, collision. But here's the twist. Neptune has no ground to hit, no surface to crater. So where does all that devastating energy go? Let's start with the moment Webb catches it. The James Webb Space Telescope sits about 1.5 million kilometers from Earth, constantly scanning the cosmos with the most sensitive infrared instruments humanity has ever built. Infrared sees heat. And when something slams into Neptune at cosmic speeds, heat is exactly what explodes outward. Webb's NIRCam, its near-infrared camera, would be the first to sound the alarm. Neptune normally hovers around minus 200 degrees Celsius, one of the coldest worlds in the solar system. But suddenly, Webb detects a spike. A violent flash of thermal radiation erupts from Neptune's upper atmosphere. Not gradual, instantaneous. Within minutes, Webb's mirror instrument, the mid-infrared powerhouse, kicks in, dissecting the wavelengths of light flooding off the planet. And what it finds doesn't match Neptune's usual fingerprint. There's excess heat, way too much for normal storms. Bright spots blazing where there should only be frozen clouds, chemical signatures that have no business being there. The conclusion is unavoidable. Something just hit Neptune. Hard. Webb would also catch the shock waves. Massive ripples of pressure expanding outward through the atmosphere like rings in water, visible only in infrared. These aren't gentle disturbances. They're violent compression waves, disrupting jet streams and shredding cloud bands that have been stable for years. For the first time, we'd watch an ice giant's atmosphere react to catastrophic trauma in real time. So what actually happens when a 100-kilometer chunk of ice slams into Neptune? First, understand that Neptune isn't like Earth. There's no solid ground to crash into, just layer after layer of thick, crushing atmosphere, getting denser the deeper you go. So the impactor doesn't crater, it dissolves. As it plunges into Neptune's upper atmosphere at maybe 50 kilometers per second, fast enough to cross the United States in under 2 minutes, the friction is apocalyptic. The air resistance doesn't just slow it down, it tears the object apart, atom by atom, converting billions of years of frozen potential energy into pure searing heat. We're talking about millions of megatons of explosive force, the kind of energy that would vaporize mountain ranges on Earth. But on Neptune, it happens inside the atmosphere, creating a fireball that expands in every direction. Webb captures the moment, a sudden burst of infrared brilliance, as temperatures spike to thousands of degrees in the heart of a frozen world. Then come the shock waves, massive walls of pressure radiating outward, warping Neptune's cloud structure and triggering chemical reactions that haven't occurred naturally in billions of years. The explosion doesn't stay put. Neptune's insane winds carry the disturbance around the entire planet in hours. Dark atmospheric bands suddenly brighten, light bands darken. The planet's familiar face transforms, like watching a bruise spread in fast forward. But here's where it gets fascinating. The impactor didn't just bring violence, it brought cargo. Ancient ice loaded with ammonia, carbon dioxide, maybe complex organic molecules, material that's been frozen since the birth of the solar system. When that flash heats and mixes with Neptune's methane atmosphere, you get chemistry. New compounds are forming, exotic reactions. Webb spectrometers would detect these foreign fingerprints immediately. Traces of Kuiper Belt material seeded into Neptune's skies like cosmic breadcrumbs. Scientists analyzing the data would essentially be sampling the outer solar system without ever leaving Earth's neighborhood. Neptune wouldn't just sit there and take the hit. This planet is alive with motion, and a collision like this throws its entire system into chaos. First, the heat lingers. Webb tracks pockets of extreme temperature persisting long after impact, hot zones in an otherwise frozen atmosphere, slowly bleeding energy back into space over weeks or months. Then the storms explode. Neptune already has the fastest winds in the solar system, but the sudden injection of energy cranks them into overdrive. New vortices spin up, massive tempests larger than Earth, rotating faster than anything we've recorded. Webb watches them grow, merge, intensify. Some might rage for years before finally dissipating. Neptune's famous dark spots, those mysterious storms that appear and vanish without explanation, would shift dramatically. Maybe new ones form in the turbulence. Maybe old ones disappear, torn apart by the shockwaves. The planet's entire atmospheric circulation gets disrupted, and it might take decades to stabilize. If Neptune has anything like seasons, and we think it might, given its axial tilt, this collision could alter its weather patterns for an entire Neptunian year. That's 165 Earth years of changed climate, all from one violent moment. You might be wondering, why does this matter? Why care about a hypothetical collision billions of kilometers away? Because events like this are incredibly rare. Collisions of this scale probably happen once every few million years. To actually witness one with our most advanced telescope would be a scientific jackpot that changes everything. First, it cracks open Neptune's secrets. Right now, we don't understand what's happening deep inside that planet, but a collision would churn up material from deeper atmospheric layers, dredging up gases and compounds normally hidden beneath miles of clouds. Webb would sample Neptune's interior chemistry without sending a single probe. Second, it tells us about the Kuiper Belt. We know there are millions of objects out there, but we don't know their sizes, compositions, or exact orbits. Analyzing the impactor's chemical remains would reveal what's really lurking in the outer solar system, information critical for understanding how our planetary neighborhood formed. Third, and this is huge, it helps us decode exoplanets. There are thousands of Neptune-like worlds orbiting other stars, and we constantly detect weird atmospheric signals we can't explain. Sudden brightness changes, unexpected chemicals. What if some of those are collisions happening light years away, and we just don't know what we are looking at? A collision on Neptune gives us a reference point, real data showing what an impact looks like on an ice giant. That knowledge ripples outward, helping us interpret the mysteries of distant worlds we'll never visit. So here's my question for you. If Webb actually detected this, what would you want scientists to do? Send a mission to study the aftermath up close, or keep Webb scanning for the next collision, the next cosmic mystery? Drop your answer in the comments. I genuinely want to know what you think. And if this kind of deep dive into planetary science gets you fired up, hit subscribe, because Webb is just getting started, and the discoveries pouring out of that telescope are rewriting everything we thought we knew. The outer solar system is full of secrets, and we're finally ready to uncover them. Neptune sits out there in the frozen dark, battered by storms we can barely imagine, surrounded by debris we've never mapped. And somewhere in that darkness, objects are drifting, waiting. Maybe one of them is already on course. Maybe Webb will catch it. And maybe we'll finally understand what happens when giants collide.